Hello, welcome to lecture 4. Today I am going to talk about quadrilaterals and some theorems associated with quadrilateral. This is the continuation of mathematics for class 9 based on NCERT syllabus. My name is Sangam Banerjee and details are given below. Okay, quadrilateral. A quadrilateral is a polygon. Polygon means it has many sides, so quadrilateral has 4 sides. Polygon in Euclidean plane geometry with 4 edges, sides and 4 vertices, corners. So it has 4 sides and 4 corners. What is polygon? A finite number of straight line segment with ends connected to form a closed shape is called a polygon. Polygon means poly means many, gon is angle. So you have two types of polygon, a convex polygon, a polygon with all interior angles smaller in measure than 180. So these all interior angle will be less than 180. And concave, this is a convex, and concave which goes inside. Concave polygon will always have at least one reflex angle. This is this angle. At least one of them will be greater than 180 degree. Okay, this is greater than 180 degree. 180 degree interior angles with a measure that is between 180 and 360. So arrow is also a concave polygon. This is not X here. This is just concave. Okay. Other names of quadrilateral is quadrangle, 4 angles, or tetragon, 4 angles. And if it is a 5 angles, you call pentagon. If it has a 6 angles and 6 sides, it is called hexagon, and so on. So names and properties of quadrilaterals. Okay, there are some name of this quadrilateral is called a square. I will come into detail. So what is square? Square properties: 4 equal sides. Okay, this side, these are all same measure. 4 right angles, it has 4 90 degree. Opposite sides are parallel, they should be parallel. Okay. Then diagonal bisect each other at perpendicular. So these diagonals will bisect each other at perpendicular. 4 lines of symmetry, that is, I can fold this. Say I draw this in the figure, or it has this. I draw one line here. This will overlap when I fold it. So this one line, this 2 line, this is the third diagonal, along diagonal if I fold it, okay, or along this diagonal. So there are 4 symmetry, line of symmetry, and also rotational symmetry of order 4 means if I rotate by 90, here it comes. Then if I rotate by 180, it is same object. If I rotate by 270 or 360, it comes. So there are 4 rotational symmetry. Then you have rectangle. Rectangles are what? You have 2 parallel lines. They are of equal length. And these 2 parallel lines, but all of them are not same length, unlike square. Okay, and they are 90 degree. And it has, if the diagonal bisect, it becomes a 2 piece. But it has 2 lines of symmetry. You draw a line and fold it. This will overlap. And rotational also, if you rotate by 90, it will become vertical. No, but you have to again rotate. Rotation is also 2. Means if you rotate by 360 degree, you will have 2 times same looking rectangle. Rhombus, it has 4 equal sides. Okay, 4 equal sides. This side, this side, this and this. And 2 pairs of equal angle. This angle and this angle. This one pair is same and this pair is same. Or I can again, make it, I can compress it. Still this angle and this angle is same. So this is uncompressed rhombus and this is a compressed rhombus. So these are both are rhombus. And opposite sides are parallel. So this line and this line will be parallel. This line. 2 lines of symmetry. Again, you have to rotate by 180 degree. Then only it will look same. And then again by 360. So when you go from 0 to 360, only twice it looks same. So, and rotational symmetry is 2 and 2 lines of symmetry. That is, if I draw a line here and fold it, it will overlap here. Or if I draw a line and you have fold it, or a mirror image, this will look same. Okay. Then you have a parallelogram, 2 pairs of equal side, two pairs of equal side, this one pair and this one pair, and 2 pairs of equal angle, this this. Okay, this is one pair, equal angle, and this is another pair. And opposite sides are parallel. Diagonal bisect each other if I put a diagonal, but there is no line of symmetry. Means if I fold it, this corner will come here and this corner will go here. So it is not going to look similar. And rotational symmetry of order 2, that is, I rotate by 180, it will come here, and then again I have to rotate it. So rotational symmetry means when you rotate an object by, say, by 360 degree, then how many times it will look same. So if it looks same while going from 0 to 360, it looks, say, 4 times same, then order of symmetry is 4. If it is for triangle, it will be like 3, means 3 times it will look very similar. Equilateral triangle. So here for this object, if you rotate by 360 only twice, it will look similar. Okay, and no line of symmetry. As I said, there is no line. You cannot draw one single line and a line of mirror if you place a mirror. Okay. Then the next one is kite. All of you know kite. These sides are same, and these sides are same. So two pair adjacent side of equal length. Okay, adjacent side means this side and this side are joined together. So these are called adjacent side. This side and this side are joined together. So two pair of adjacent side of equal length, one pair of equal angle. Okay, this angle, only one pair. This angle and this angle is same, but this angle may not be same because this looks slightly more angle than this. Okay, but this angle is so one pair of equal angles. Diagonal intersect. If you take a diagonal here and draw here, it will be perpendicular. And only one line of symmetry. That is, you cut here and then you fold, you draw a line here, fold, it will overlap. But there is no other. If you do it here, this small triangle will fall on it will not overlap. So there is only one line of symmetry. Arrowhead, two pairs of adjacent side of equals. Similar to this, only thing is inverted here. Okay, two pairs of adjacent side. This side and this side is same length, and this side, this is an adjacent side. This side and this side is same length. And one line of symmetry. Similarly here, if I draw a line here and if I fold it, it will overlap. Otherwise, it will not overlap. And now trapezium. One pair of parallel line, only one pair of parallel line. These are not parallel, these two. And isosceles quadrilaterals of this kind have one line of. Here you don't have symmetry, you see. Here you don't have, you do anything you do, it will not. But if it is isosceles, means this also is same. Okay, this angle and this angle, then of course I can have one line of symmetry. Otherwise, if these two lines are not of same length, then it is not it will not have a line of symmetry. No line of symmetry. So from these definitions of quadrilaterals, now we will come to, there is something called cyclic quadrilateral. Okay, so if you have a quadrilateral, this is a quadrilateral, and you can draw a circle around the quadrilateral. This quadrilateral is embedded inside, and each corner should touch the circle. Then it is called a quadrilateral. It can be regular or it can be irregular. Okay, so let me read. Quadrilateral whose vertices all lie on a single circle. This circle is called the circumcircle. This is called the circumcircle or circumscribed circle. Okay, and the vertices are said to be concyclic. Okay, or cyclic. Similarly, one can have cyclic polygon. So even you can have pentagon, cyclic. So all the edges has to be, or a hexagon, okay, or octagon, septagon. So all the corners has to be touching the, or in mathematical term you say vertices. All the vertices should touch the circle. Now, whether the polygon is regular or irregular, say if I take triangle, okay, equilateral triangle is a regular, say if I say, and if I draw some other angle, whatever the triangle is, okay, the sum of the interangle of a polygon, of a typical polygon is the same. Suppose it is a square, or I make it a parallelogram, or I make it a rhombus, this quadrilateral, the sum of the interior angle will be same of all this. Okay. So for triangle we know it is 180, and so I write 1 into, this is the formula. We will prove this formula now. This is summation of interior angles of polygon is n minus 2 into 180 degree. And what is n? N is the number of side. For triangle n is 3. 3 minus 2 into 180, that is 3 minus 2 is 1. So sum of the internal angle is 180. Sum of the square is, say side, 4 sides are there, 4 minus 2 is 2. 2 into 180 is 360 degree. Okay. I can break this polygon into triangles. So how many 2 triangles are there? So 2 180 plus 180 360. So similarly for n equal to 5, I can break into 1, 2, 3, 3 triangles. So I have 180 plus 180 plus 180. So 540. So that is 3 into 180. So how many side? N is 5. 5 minus 2 is 3. So that's why this formula is n minus 2 into 180. And exterior angle of a polygon, exterior angle means if I extend this side, okay, I will get one exterior angle. I extend this side, I will get another second exterior angle. I will extend this, I will get third, so I extend this fourth, and I extend this fifth. So okay, so I can take this angle and put it here. Angle 1, angle 2, angle 3, angle 4, angle 5. Okay, and this will be always 360. Okay, always. Also true for irregular polygon. Okay, even if the polygon, you know, like all the sides are not equal, but it's a pentagon or even square, any polygon, the sum of the exterior angle is always 360 degree. Okay, just try with other triangle, square, hexagon, and you see whether it is. Okay. Take a protractor where you can know get the angle and sum it. Okay, approximately you will get 360 because you may not be very accurate in measuring the degree, but it will be 360. It has to be equal to 3, exactly equal to. Also, it is true for cyclic and non-cyclic polygon. That means if the polygon is not what is cyclic? Cyclic is where all the vertices touch the circle, and non-cyclic is where vertices are not touching the circle. You can have some polygon where some of the vertex may not touch. You cannot draw a circle around it. We will come across this. In non-cyclic polygon, all the vertices cannot be circumscribed. Okay. We'll see one example. See here, one polygon is there. This is rhombus. Now you have this this radius, but this distance is not. So it is not possible to circumscribe this one. So all polygon cannot be circumscribed. Okay. So all triangles are cyclic, have circumcircle, but not all quadrilaterals are. This is an example. You just give it a try. Example of non-square rhombus cannot be cyclic. Okay. This is, you know, slightly less tapered. Non-cyclic polygon we will not discuss in this. This is beyond the scope of class 9. Non-cyclic, we will only talk about cyclic polygon. How do you circumscribe a circle around a triangle? Touching all the vertices on the circle. So how do you draw a circle which will touch all the? So it is very simple here. You bisect the side. You take a compass, you know, where you put pencil, and you draw an arc from. You take measure this, draw one arc. Then from point A you make same thing, and similarly you draw an arc here and join these two. So this will bisect this line. This is the way to bisect a line. Okay. So similarly, you take two sides. This side also you can do similarly. You take a compass, draw an arc here. You take from B also you do, and similarly you do from again same CB length. You take this, draw an arc from B and from C. Okay, and you join this point and this point. So these 2 points will intersect somewhere here. Okay, so this is the center. Okay, and then you just take the center and take a compass. This will be your radius, and draw a circle. This distance is very similar. Okay, this distance will be also similar. You try it out. You can also have this kind of a triangle. Okay, if you bisect, it is not always that the center, this point, intersection point will be inside the triangle. It can be outside also. Say here it is outside. I have bisected this line, and I intersected, it goes out. So now you take this as a radius and you draw a circle. You try it out. Okay, this is a good exercise for you. Similarly, one can bisect, you can bisect AC also, but 2 is minimum 2 is enough. Okay. In quadrilateral, sometime it doesn't happen, we will see it. Similarly, for quadrilateral, construct perpendicular bisector for all 4 sides of the quadrilateral. Okay. If they all cross at the same point, then that point is the circumcenter of the quadrilateral. So similarly for quadrilateral also you can do it. I did it here for triangle, so that quadrilateral, we'll see, we will do this if time permits. Here you have made a circle, okay, but you can also, inside the triangle, you can inscribe a circle. Okay, how do you inscribe? Here I have bisected the sides, but for inscribing you have to bisect the angles. Okay, so how to inscribe triangle? A circle in a triangle where all the side touches tangentially to a circle. So what tangentially means, it will just touch it. Okay, this angle will be equal to this angle, and it is just touching. That is a tangent. A tangent line on a circle will just touch, and the angle will be same. So these triangles are called tangential triangle. Okay. So bisect any 2 angles. As I said, you bisect this. You draw one straight line here. Take this measure, and with a compass you draw one, and from this point also you draw. Okay, and similarly you draw this side also, this 2 arc. I have not drawn here. You draw it. So this will bisect. If you join and extend it, it will bisect this angle. And similarly you bisect this angle. So this will, and you extend this line, and this bisector, angle bisector. This you extend it, and it will join somewhere here. And then from here you have to know the tangential point, that will be the radius. So how do you draw this one? You again draw some arc FG, I call it. So I get this length, FG, I get a length. Okay, and I again draw an arc here, and from G1 arc and from F1 arc using a compass. So from this point you draw a line straight. This will be perpendicular, and now you got the radius, and draw from this point. You can, same thing you can do here, but it will be same. Okay, so you draw a circle with this radius. Okay, so what are step 1? Bisect 2 angles, draw arc FG. Step 3, perpendicular from D to line AC, you draw, and draw circle with the radius DE. So similarly, tangential quadrilateral, okay, you bisect angles. This angle you have bisected, this you have bisected, and then again from this you draw a circle, and take this point and this point, and draw, you bisect this length, and from O you drop it here. Okay, you try it, you will see it. Okay, now I have told you how to bisect an angle and how to bisect a side. Okay, and similar step you do it, you will get a center point. This is intersecting point, and this is the radius, OE is the radius, and you draw. So bisect angle A and angle B, draw perpendicular from O to line DC, this line DC, draw circle with radius OE, and this is the radius OE. Now we will come to some theorem. Theorem 8.1. A diagonal of a parallelogram divides into 2 congruent triangles. Okay, this is a diagonal of a parallelogram divides into 2 congruent triangles. That is, this triangle ADC and ABC are same. So how do you show that? Of course, you take this line as parallel. Say, suppose I take this line as parallel, and if I draw a transversal, so then this line, this with respect to this parallel line, and this line with respect to this parallel, they will be same. And similarly, if I take this parallel line and I draw transversal, so this angle and this angle will be same, which we have discussed earlier. So since this is your, and this side is also same common, so from angle, side, angle, and this angle is same as this, so angle, side, angle, triangle ADC is equal to triangle ABC. Okay, here I have written it. So when anything is given to you a figure, you first try to think how to do it and then you write it. That is always easy. Don't start writing, first figure it out. I will show you how to figure it out things as we progress. In a parallelogram, opposite sides are equal. Okay, it is very that is by definition. Okay, opposite sides have to be equal. Theorem 8.3, if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. It says that each pair of opposite sides are of a quadrilateral is equal if this and this and this and this, okay, then it is a parallelogram. Because of course if it is not, this gets fixed actually. If you see, if I try to make it small, then this line will come below and this. So this is how the parallelograms are. This two parallel line and this parallel line, and this line and this line will be same, and this line and this line will be same. Okay, and this is how you can also prove it, that okay, like this angle we have seen that they are congruent. So this angle and this angle, I know this double arc I have drawn single, this plus this and this plus this is same. So they are same angle for this parallel line. Similarly, this angle and this angle will be same. So you just prove using triangle congruence rule. In a parallelogram, opposite angles are equal. Here I have shown is the opposite angles are equal. Again, use this only and just extend and write it. Theorem 8.5, if in a quadrilateral each pair of opposite angle is equal, here opposite angles, in a parallelogram opposite angles are equal. If each, in a quadrilateral, if there is a quadrilateral and each pair of opposite angle is equal, then it is a parallelogram. Then is this angle, this angle, this angle and this angle are same, has to be parallel. Okay, now theorem 8.5, if in a quadrilateral each pair of opposite angle is equal, then it is a parallelogram. Of course, we have shown that for a parallelogram, each pair, this angle total, this angle should be same, and this angle should be same. So theorem 8.6, the diagonals of a parallelogram bisect each other. So diagonal bisect each other means when you, these diagonals of a parallelogram, they will bisect each other, means this arm will be equal to this arm and this arm. So these diagonals bisect each other, they will be. So how do you show that? Again, very similarly, see here, you should first, you don't have to remember like this. You just see the figure, draw the diagonal, then whatever you know, okay, I know that this angle has to be equal to this angle. So I know that if this is a parallel line, suppose D and BC are parallel line, okay, and if I draw a transversal along this diagonal, then the angle between this parallel line and the diagonal and this parallel line and the diagonal, okay, they will be same, which you have seen it, okay, alternate interior angles. So I have got for triangles say DOA and BOC, two angles are just two same angles. This angle and this angle is same. This angle is same. And since these are this line is parallel, so this distance, as I mentioned, they has to be same. So again, from angle, side, angle, this triangle and this triangle is congruent. Okay. So then I can always say that DO, this is this length, because it's congruent, DO from CPCT, corresponding part of congruent triangle, and this is a similar this length. So DO is equal to BO. So this line is bisecting, line AC is bisecting DB. Okay. Similarly, I can take this parallel line and this parallel line. I get angle here. This angle will be equal to this. Okay. And if I draw another diagonal opposite, I will get this angle is equal to this. So this angle, and this is the same side. Okay. And so they are congruent. Now you will say, why I have not used angle. At first written angle, but angle, there is a problem. Now I said that it can be similar. So one side you have to include one side for congruency. So if you do angle, then you may have angle same, but the sides will be can be of different length. Still you can have angle. So they are not congruent. Congruent means exactly same size and shape. So theorem 8.7. If the diagonal of a quadrilateral bisect each other, then it is a parallelogram. That is, if the diagonals are bisecting each other, then it is a parallelogram. I am not proving it here, but I will tell you how to prove it. Okay, so that you should also know how to go about doing it. Suppose he is saying that this is a diagonal and they are bisecting each other. That means it is given that this length and this length, OD and OC is same, and OA and OC is same. So this is given. Okay, a quadrilateral is given. Okay, and I know also that this, I draw this quadrilateral, and this angle, you know that opposite angles are same, that you know it from the axiom. So now this side angle side, so these two triangles are congruent. So if they are congruent, these sides are same. Okay. So similarly you prove for this also. Okay, this triangle also, this and this one also will be similar to DOC, will be similar to AOB, or not similar, congruent to AOB. So from there you can prove that if the diagonals are so this pair or this opposite sides are equal length, you can show from the congruence, and this side is also equal. So this you should do it by yourself, and I'm sure you are by now you are an expert doing such things. So thank you. See you in the next lecture.